this is the uni-max workshop. I am Tomasz Krasinski, and together we will try out a new technique. Sharp tools are a prerequisite for clean, fast, less strenuous, and safer work in the workshop. Even the highest quality tool can dull sometimes. Lower quality tools dull faster, while high quality ones take longer. Most tools can be successfully sharpened, and this also applies to saw blades. While simple tools only require basic manual sharpening, blades with a large number of teeth and high precision demands need a device, like a saw blade sharpener, for perfect grinding. Maintenance and servicing of machines and tools are not among my favorite activities. But working with well-functioning machines and quality, sharp tools satisfies me much more than struggling with neglected equipment. And so, from time to time, we must dedicate a little attention to it. Cheap saw blades with small carbide tips aren't even worth sharpening because the cost of the service is higher than the price of a new blade. Besides the fact that these blades don't keep their edge sharp for long, working with them is noisy and slow because their quality matches their price. They wobble and have higher friction. I believe that almost everyone has succumbed to the lure of a good deal and has some such blade in their workshop. With your own saw blade sharpener, you can sharpen even those blades for which custom sharpening wouldn't be cost-effective. However, for more serious work, it's definitely worth investing in quality blades. Higher quality materials have many advantages. Compared to cheap blades, working with them is better in every way. The tips made from sintered carbides are also significantly larger, so they can withstand multiple sharpenings. When you have your own sharpener, you don't have to hesitate to buy blades with a high number of teeth, as their sharpening would otherwise cost you hundreds of crowns. But enough theory, let's try out the sharpener itself. Both on a cheap blade and on a branded blade with quality edges, the sharpener comes disassembled into two parts. First, you need to attach the base for securing the blade to the main structure. A solid connection is ensured by two screws. Attach the included rubber feet to the massive cast iron base of the sharpener and screw on the feet handle. The correct position of the grinding wheel is with the flat surface facing the motor, thus the conical surface is directed away from it. If the sharpener, like mine, seems to have the wheel mounted backwards, it's as simple as loosening the locking nut with 2 wrenches, turning the wheel around, and tightening the nut again. Then you just need to secure the saw blade and set the sharpener. Besides the diameter of the blade, you also need to follow the sharpening angles to properly sharpen both the face and the back. Additionally, the stop must be adjusted so that all the teeth are sharpened evenly. Finally, test the sharpening of the first tooth, marking it with a permanent marker, and if you're satisfied with the result, continue sharpening the other teeth. When sharpening, only grind off the necessary part of the tooth. Removing too much material unnecessarily reduces the number of possible sharpenings. And there's a rule. It's better to sharpen more often and less than less often and more. The faces of the teeth are sharpened with the flat surface of the grinding wheel. First, loosen the locking screw. Set the axis of the grinding wheel to a horizontal plane and tighten the screw. Carefully loosen the other locking screws, then appropriately select the appropriate centering insert and screw it in. Use the wheel to set the appropriate distance. Gradually fine-tune the distance of the head and the angles of the guide and sled like this. The path of the sled must be parallel to the plane of the blade. The sled is extended to the stop, and the face of the cutting insert is completely aligned with the plane of the blade. At the same time, there is sufficient clearance from the body of the saw blade. Set the angle of the tooth face, which can be, for example, 15 degrees positive or 5 degrees negative. Tighten all the screws. Clamp the disc in the feeding sled so that it can be rotated manually with reasonable resistance. Check the free movement and position of the sled stop and the rigidity of the other components. Extend the disc and turn on the motor. Rotate the saw blade so that the grinding wheel faces the gap between the teeth and push the sled to the stop. Gently press the front face of the tooth against the disc and remove the necessary minimum of material. Move the sled out. Check the sharpening. Once you are satisfied with the result, set the stop to the face of another tooth. Mark the first sharpened tooth appropriately. Rotate the disc to the next tooth and continue sharpening like this. Sharpening the backs of the teeth. Perform the sharpening of the backs only after sharpening the faces. The surfaces of the backs are sharpened with the conical surface of the grinding wheel. The surfaces can have different angles or arrangements. There are straight, alternating, or even trapezoidal shapes, and they usually alternate every other tooth. Each set of such surfaces needs to be adjusted and ground to separately loosen the screw and set the angle of the grinding wheel. While setting the angle of the front is precise, for the back it is more empirical, and you need to adjust both the rotation of the entire bed and the clamping sled. The next step is similar to the previous one, with the sled's path set parallel to the surface of the conical area of the wheel. You can note the resulting angle of the ramp to speed up the setup during the next grinding of the same wheel. Because the tilting axis of the grinding wheel is not in the axial plane of the saw blade, you need to readjust their relative position, or rather the distance, after tilting. Since the abrasive of the grinding wheel is diamond, it can also handle quality hard metal or sintered carbide. In addition to saw blades for wood, you can successfully sharpen blades for cutting steel. But be prepared for it to be more time-consuming, as they often have a high number of teeth and different profiles, which means there are more surfaces to grind. A sharp blade penetrates the material more easily, so you don't have to push it as hard during the cut. Thus, physical effort is reduced, as well as the risk of your hand slipping. So, working with sharp tools is even safer. In conclusion, I want to point out that any sharpening done by hand depends on the experience and skill of the operator. So don't lose your head if it doesn't go as you envisioned right away. With a little patience and a relatively simple sharpener, you can achieve wonderfully sharp saw blades. Thank you.